So being aware of the presence of the protons, the neutrons, and electrons inside the atoms made it opened up a whole area for study and helped us to understand the atoms a lot better. So the number of protons that are in the nucleus of an atom is what identifies that atom as being a particular element. So here's an illustration of helium balloons. So in these balloons is helium gas. Helium gas is composed of helium atoms, and in each helium atom there are 2 protons in the nucleus. Every helium atom has 2 protons in its nucleus. That's what makes it helium. Here's the top of a soda can. Aluminum. In the nucleus of aluminum atoms, there are 13 protons. Every single aluminum atom has 13 protons. Now, stuff can happen with the neutrons and with the electrons. It's the number of protons that identifies what element does this atom belong to. So if you think about people, right, we can change the way we look. We can dress up as something crazy for Halloween. We can cut our hair or bleach our hair or wear different kinds of clothes. There's lots of things that you can do to change your appearance. Does it change who you are? No. You can change what you look like, you can change how you act, but you can't change who you are. It's just who you are. So the number of protons is like your personality, your soul, right? It can't be changed. That's how it is for an aluminum atom. It's got 13 protons. That doesn't change. Could it take on or get rid of some electrons on the outside? Yeah, it can and it does. And that affects how it interacts with other atoms. But the number of protons is what identifies it. So we call the number of protons the atomic number. It's given the symbol Z. I don't know why, but it is. There it is. Symbol Z. So when we look at the periodic table, this is a list of all the known elements, and they are ordered by their atomic number, the number of protons in the nucleus. So when we look at one of these little boxes, so this one's beryllium. So here's the chemical symbol for beryllium. This periodic table has the name of beryllium here as well. And above the chemical symbol is a whole number, 4. That's the atomic number. That tells me that beryllium atoms have 4 protons in their nuclei. So the chart has a little bit of a funky shape, but if you go from left to right, here's number 1, number 2, 3, 4, 5, 6, 7. It goes across like that. And then there's this little glitch down here. If you look at the periodic table that we have on the wall in the lab, it was partly because of the amount of space above the chalkboard that was available to hang the periodic table, but it also ends up being convenient. If you notice here coming across 55, 56, 57, 72, what? We really should take a pair of scissors, cut the periodic table, pull this side apart, and bring this up in here. And look at the periodic table on the wall in the lab today, and that's what we did. It made it fit on our funny-shaped piece of wall better. Why don't we do it on all the periodic tables? I think the most practical reason is it doesn't fit well on a piece of paper. These are called the lanthanides because they come after lanthanum. The actinides because they come after actinium. These guys are pretty rare elements. We don't use them very much. They're important. They need to be here, but we've cut them out and stuck them down here. So 57, 58, going through here to 71, and then back to 72. And it just continues on. And when we get here to actinium, we jump down there and go across and up again. So they're ordered by their atomic number. Any questions? So each element has a symbol. Some of them have kind of long, hard to pronounce names, and it gets real tedious if we had to write out all of the element names all the time. So we use a shorthand, the chemical symbols. Each element has a symbol. It has 1 or 2 letters only. The first letter is always capitalized. The second letter, if there is one, never capitalized. And it's really, really important to write those properly. Most of these symbols are based on the English name. The symbol for carbon is a capital C. The symbol for cobalt is CO, because C was already taken, right? But some of them are based on Latin or Greek names, and so they don't seem to make sense if you think about the English. So the modern name for this element is potassium, but its symbol is K. And you may wonder, how the heck do you get K out of potassium? Well, its historical name was calcium, which started with a K. Sodium has the symbol Na because its original name was natrium, because it was isolated from seawater. Lead has the symbol Pb because its original name was plumum. Think about lead pipes, right? And plumbing, right? So the plumber works with pipes. Well, that's because they used to make pipes out of lead before they realized that wasn't a great idea. And so the plumber worked with lead. The symbol for lead is Pb. Mercury is Hg, iron Fe. So some of these are a bit weird. I'm sorry, you're just going to have to learn them. Okay, we need to know the element names and symbols. This is my favorite element. Okay, I got 2 giggles. Good enough. So find the name and atomic number for each of these elements. So Na. Anybody know what Na is? Sodium. So what's the atomic number for sodium? Periodic table's not very convenient for me. So we find it on here. It's up there in the upper left corner. It's 11. So the atomic number is 11 for sodium. How about Ni? Nickel. We find nickel on here as element number 28. It has 28 protons in its nucleus. How about P? Phosphorus. Do your best spelling these correctly. Phosphorus 15. And Ta, that's an odd one, huh? That's the one I wouldn't expect you to have memorized. Can anybody find it? Yes, number 73. Tantalum. So every element has a name and a symbol. Just last year, they named a bunch of new ones. No, yeah, this periodic table isn't quite up to date because we still have some unnamed ones. They have given names now to number 113, 115, 117, and 118. So when we write symbols, CO is the symbol for cobalt. If we get sloppy and put a capital O instead, that's carbon monoxide, which is very different. Cobalt is a metal, carbon monoxide is a gas. So the size of the letters that you make is important. SN is the symbol for tin. Some students like to write their letters in all caps, and they just have small capitals, and so they'll do it like this. I don't care what you do for the rest of your handwriting, but when you write the element symbol, don't do that, because that looks too much like SN, which is sulfur and nitrogen. So that's not good. It needs to be a lowercase n. And we also run into problems with that. Is that a letter or a number? What is that? It could be a 1, it could be a capital I, or it could be a lowercase l. You gotta be careful. So I like to make my capital I's with the bars on the top and the bottom. So that would be iodine. And then things like chlorine, Cl, I make those L's a script L, so they're clearly an L, because otherwise Ci or Cl, kind of hard to tell. That could be carbon and iodine. If we write it like this, then it becomes a little clearer. There is a compound like that. So we need to be careful when we write these symbols. The symbols are to save us from writing out lots and lots and lots of letters. But we need to be very careful that we write them exactly the right way. Okay? Any questions?